Solve for minus 180 degrees is less than or equal to x, which is less than 180 degrees. The equation 3 sine squared x plus sine x plus 8 is equal to 9 cos squared x, giving your answers to 2 decimal places. So the first thing we want to do is get this entire equation in terms of only one thing, because here we have sine and we have cos, and this makes it a lot harder to solve. And so just because we have a sine squared and a sine, but only one cos term, so we have 2 sine terms and 1 cos term, it might be easier just to get this in terms of sine. So we know the identity sine squared x plus cos squared x is identical to 1. And therefore, cos squared x is identical to 1 minus sine squared x. And so, in the equation we're given in the question, if we were to replace cos squared x with 1 minus sine squared x, that's an 8, we will now have everything in terms of sine. So if we were to expand out this bracket, we are left with 9 minus 9 sine squared x. So now if we add 9 sine squared x to both sides and take away 9, we're left with 12 sine squared x plus sine x minus 1 is equal to 0. And you can now see that we have a quadratic. And although it's in terms of sine, as opposed to normally maybe an x or a y or another letter, it's the exact same rule. It's the same way that we would solve any other quadratic equation, except we have sine and sine squared. So the first thing we want to do is, if we solve this by inspection, we need to find 2 numbers that multiply to make minus 12, because that is 12 times minus 1 is minus 12. So we need 2 numbers that multiply to make minus 12 and add to make 1, because of this, just plus sine x. And these 2 numbers happen to be 4 and minus 3. So if we split sine x up into plus 4 sine x minus 3 sine x, as this is the exact same thing as just sine x, it's now easier if we factorise these first 2 terms. We can see that 4 sine x goes into both of them. See, we're just treating sine x and sine squared x as a letter, say it was y. And that is another way you can solve this, is you can say that sine x is equal to y and replace sine squared x with y squared and sine x with y, if that's more comfortable for you to visualise it in that way. You'll get the exact same answer. It is just a different way of doing it. But if we do it like this, we take 4 sine x out of both of these terms, and we're left with 3 sine x plus 1. And here we can take minus 1 out of both sides, and we're again left with 3 sine x plus 1. This is all equal to 0. When we factorise this, we're left with 3 sine x plus 1 multiplied by 4 sine x minus 1 equals 0. And therefore, 3 sine x plus 1 equals 0, and 4 sine x minus 1 is equal to 0. So if we rearrange these to get them both in terms of sine x, we have sine x here is equal to minus a third, and sine x here is equal to 1 over 4. So if we solve this by using arcsine, or the inverse, here we get the x, and we just put this into our calculator, we get that x is equal to minus 19.47 degrees. And if we remember back up in the question, we want between minus 180 degrees and 180 degrees, and this falls in there into this these limits, so this is a valid answer. However, if we remember and if we draw a quick sketch of the graph of y equals sine x, quite a messy sketch, we know that if sine x is equal to minus a third, there are two solutions here. And we can say that this one is minus 19.47, and the other solution is here. And the way we can find this one is using the rule for sine graphs. And to find this one, we would do minus 180 degrees, take away minus 19.47. And if we put this into our calculator, we get this is minus 160.53 degrees, because remember, this is all to two decimal places as specified in the question. Now, for this next one, where we have sine x equals a quarter, if we were to draw this line on the graph around here, and we put it into our calculator, the first result we get is 14.48. And it's safe to assume that that is this solution here. And to find the next one, similar to before, if we do 180 take away 14.48, we end up with 165.52 degrees. And we can say that that is therefore this solution here. So now we have four solutions, and these are the only four solutions, because if we remember, we are within this range of between minus 180 and 180 degrees. So these are our four answers, and if we write it out a bit clearer, all is one. And if we do it in order, we can say that x is equal to minus 160.53 degrees, minus 19.47 degrees, 14.48 degrees, and 165.52 degrees, and this is all to do two decimal places. Now, there are 6 marks available for this question, and so our first one comes in the form of a method mark, and it's from using the fact that cos squared x is identical to 1 minus sine squared x, and substituting that into our formula, so that's our first method mark. And then we get an answer mark for then saying that this therefore ends up in this form here, 12 sine squared x plus sine x minus 1 equals 0. We then get a method mark for factorising this in the form that we have here, and a further answer mark for obtaining sine x is equal to minus a third and a quarter. So both of these get us another mark. And we get a further mark from using, it's called arc sine, which is the inverse of sine, to obtain two correct values, which in this case were this one and this one, because these were the ones that we obtained from a calculator. And we finally get our last answer mark for getting these 4 values to two decimal places, and these are the answers to the question. So part B is asking us, hence find the smallest positive solution of the equation 3 sine squared 2 theta minus 30 degrees plus sine 2 theta minus 30 degrees plus 8 is equal to 9 cos squared 2 theta minus 30 degrees, giving your answer to two decimal places. Now, if we look at the equation given in part A and part B, we can see that they're identical, apart from the fact that x has now been switched out with 2 theta minus 30 degrees in each term. And so we can say that x is equal to 2 theta minus 30 degrees, because the fact they're the same equation. Now, given that we already have 4 values for x that we worked out in part A, we can say that if 2 theta minus 30 degrees is equal to x, then this must be equal to one of these 4. Now, given that we want the smallest positive answer, we may as well start with the smallest value of x and see if this works. So given that the smallest value of x is minus 160.53 degrees, if we were to use this, and if we think to solve this for theta, we'd need to add 30 degrees to both sides. Now, if we add 30 degrees to minus 160, we would still have a negative number on our right-hand side. and therefore our final answer for theta would not be positive, which is one of the specifications in the question of what the solution needs to be. And if we're not going to get a positive solution, this cannot be the value of x that we need to use. So we can say that this is not the value of x we should use. So the next smallest number is minus 19.47. And if we were to use this and try adding 30 degrees to both sides, you can see that we do end up with a positive number. We get 10.53 degrees to two decimal places. Now, if we divide this by 2, because we've now got the smallest possible positive number, because if we used a number bigger than minus 19.47 as x, we just get a larger number for theta. But the question specified that they wanted the smallest positive value. So if we use this, divide both sides by 2, we get that therefore theta is equal to 5.26, as this is to 2 decimal places. And remember, we're using the whole value of 19.47, not just the rounded up version. And this is the smallest positive solution of the equation. And the 2 marks available in this question, the first one is awarded for setting 2 theta minus 30 degrees equal to minus 19.47 degrees. And then we get an answer mark for saying that theta is equal to 5.26 degrees.